Hello, Christina and I are here today to talk to you about the CAMIS project, that stands for Comparing Analysis Method Implementations in Software. It's a standard disclaimer. So I'm Lynn. I've been in the industry for more than 20 years and I prefer doing my stats analysis in SAS. Welcome, Christina. Christina's newer to the industry. She learned object-oriented programming in school, and so she prefers using R. Christina and I work together. We do analyses. Sometimes I might get a result, it doesn't match Christina's result. And sometimes it can be pretty close, sometimes it can be quite far away. And when this happens, we have to look at the documentation. We start looking at the SAS documentation, the R documentation, and we try and find what is going on. Like, is SAS doing something different than R? And this takes a really lot of time because you have to get right down to sometimes the equations and also the papers, like Bauer 1972, dig out that paper, look at what the equation is and see if there's something different. So obviously this is going to be a huge problem if we find these differences, say post database lock, and we are on a critical path of study reporting. So we want to try and do this obviously at the dry run stage, or and so the key thing to start with is making sure the documentation of what you're going to do specifies clear requirements. If you don't have a clear requirement or what method you're using, then it's highly likely you're not going to get the same results in the software. If you do get different results, we're introducing you today that you should look at the CAMIS repository, and we'll show you what the CAMIS repository looks like on later slides. But we also need to think about the tolerance that we're looking at. Obviously, a different number to 7, 8, 9 decimal places doesn't really matter. It's close enough. And depending on what analysis you're doing, there might be convergence differences that cause slight differences to 4 or 5 decimal places, and you might consider that to be enough. So think about the tolerance you're looking at. Obviously, a p-value to the second decimal is a different p-value. That probably does need investigation, and the investigation is what takes time. So how does CAMIS help? The CAMIS repository looks a little bit like this, and I know it's quite small on your screen, but there's a methods column. The methods are broken down into all the different types of analysis that we've covered, and we're happy to add more analyses. There's a column for R, SAS, Python, and then the key thing here is the comparison column. So if you're finding differences, your first point of call is to look at the comparison column and see if there are known differences between SAS and R that will help you see what's going on. And obviously there's lots of gaps in here, and we would like all of the open source community to contribute and help us complete this table with information. So the first thing that might be going wrong is the defaults. We take standard analysis like a Kaplan-Meier plot, and you might have confidence intervals on that. You can do confidence intervals in SAS and R, but if you don't specify anything in your code, then SAS will use the log method and R will use the log method. So you might get different confidence intervals. You can change these methods using the conf type or the conf type in SAS and just set those options. And if you do that, the results match mostly, but actually the CAMIS repository also tells you there are specific use cases when they might also not match. Looking at Cox proportional hazards regression, the defaults are different for how they handle ties. So you need to be specifying what ties you're using to ensure that you're using the same methods, and that enables you to get the same results. Another useful point about CAMIS is that it can detail common coding mistakes, places where maybe just Googling how to do something isn't very clear, maybe the literature, the documentation with the software isn't very clear, and if it's something that we commonly do in pharmaceutical research, for example, comparing treatments, using logistic regression, it's useful to specify what your treatment reference is. It's useful to have a look at how you're parameterizing your model. All that is included in the CAMIS repository. It's also useful to let you know what packages may or may not be being maintained. Now, one of the issues with R is if you Google, I want to do McNemar's chi-square test in R, different packages might come up and you have to choose which one to use. An example here was the EpiBasics package. It was categorized as high risk by the risk metrics package. And when we tried to replicate its results against SAS, we got different confidence intervals. So we contacted the author and he actually came back and said he can't really remember how the confidence intervals were being calculated and he's not maintaining the package, so he recommends it not to be used. So in CAMIS, we tell you to use the VCD package instead for the confidence intervals. And this is all documented in these tables of how to do it in SAS and R and differences between them. The other thing it does is helps to find bugs in the community. So when we were looking at our best package to produce Klopper-Pearson confidence intervals, we found it matched the CardX package and the HMIS package, except for two specific use cases where the proportion was either 0 responders or 100% of responders. And we went back to the package authors, let them know that why doesn't it match, and they actually updated the package, fixed the bug, and they re-released it on CRAN for us. So CAMIS can really help improve the reliability and the confidence that we have in our packages when we've shown they replicate against other packages and against SAS. So the key impacts that I've described, it highlights differences in the methods. It can be continuity corrections, different defaults. Some options and methods aren't actually available in both softwares, but at least you know that. It can detail common implementation mistakes. It helps identify bugs. And so we hope that CAMIS through this kind of community effort to document it centrally, it will become a trusted resource for industry guidance.
So let me talk you through an example really quickly. So this is an example of, for instance, something that Lynn and I might be given, where for a study, we're comparing two treatments, A and B, in patients, and we want to do a Wilcox rank sum test and analyze a change from baseline post-challenge, and we're going to report the Hodges-Lehmer estimate of the median difference between B versus A and the corresponding 95% confidence interval and associated p-value. That is great. So now, normally we'd say, let's start with looking at CAMIS and see what it says, but for this example, I'm going to walk you through how do you even begin to think about doing this comparison if, for instance, there's nothing available on CAMIS. So the first thing to think about when you are starting these comparisons is to ask yourself some three basic questions. First, is this method available in both software? Then, are there multiple ways to do this in each software? If there are, we want to make sure we're just selecting one. It's much easier to do a one-to-one comparison than trying to compare SAS with 5 different R packages at the same time. It will be much easier if you just do everything stepwise. And then finally, are there any considerations we need to make when choosing the data set? So what Lynn was talking about before around with the Cox proportional hazard in terms of tie handling, things like ties, extreme values like 0 or 100% can cause issues. So do we have extreme values we want to be making sure we're including in our data set so that if we're in an early dry run phase and so we can't see our data, we want to make sure that when we get our final data that we don't actually have any extreme values. So great. For this example, we're going to talk through the Wilcox rank sum and the Hodges-Lehmer. So are these two methods available in both softwares? That's an easy yes. The next question is, are there multiple ways to do this in each software? And when I look through R, I found, after a quick Google, 3 packages. Now, there's probably more packages that can do this, but we're going to just talk through these 3. So the first one, stats. This is part of base R and would be my first selection basically always. If something's available in base R, there has to be a good reason for me not to use that like base version. The next one is a package called pairwise CI, and finally a package called coin. Great. So I started to use the base R one and using a data set that had ties, because that's kind of a weird value that happens in Wilcox and rank. I found out that stats can't handle the ties. Okay, fair enough. So now I need to do the pairwise CI and the coin. So let's compare those packages. When I start comparing packages, I ask myself a series of questions. First being, is the package actively maintained? This is just going to be looking at when it was last published, things like that. Then I look at, is the author known in the field? If, Wilcox was writing a package about the Wilcox rank sum test, I would believe his package is probably the exact method that he wants you to use. So those sorts of things can be really helpful. And as we look at newer methods, there are more and more now authors are writing the packages associated with their methods. Then, does one package have better documentation than the other? As Lynn said at the start, a lot of this kind of comparison work is really a matter of digging deep into the documentation. So when one has better documentation, it will just make your life easier if all else things are being equal. So then I think about looking at the community adoption. So this is going to be things like the number of downloads, maybe you're looking at risk metrics, maybe they'll look at the number of packages that depend on it. Those sorts of things can really help you get a sense of how well used is this by the community, and that can really tell you what, if this is the more standard way of doing this methodology. And then the final question I think about is, can the packages handle different edge cases? Because Oftentimes those edge cases are, in this case, it's the reason we're looking outside of stats. So being able to handle those is super important. So the first place to start answering all these questions is, because when I'm doing these sorts of comparisons, I don't want to spend 3 hours comparing packages before I even start to compare the methods. I'm going to start scanning the CRAN webpage, and that's like a great place to start to get a good sense of most of this information. So starting with Pair ICI, if I look at this, I can see the last published was 2019. That was a while ago. I can see that it doesn't have a website, which, doesn't mean a huge amount, but it does make me a little bit nervous about it. I don't see any references to peer-reviewed paper on this page. So again, it's not the end of the world, but it might be something to consider. And then finally, I'm looking at some things. Notice that also it actually depends on Coin, which is the other package that I'm considering using. So again, I'm like, oh, maybe I should just use the Coin package instead and go directly to that source. The final thing is I'm looking at the author. I don't really know this person. I don't know their name off the top of my head, but they are at a university, so that gives me some like positive feelings. Universities tend to be like good for this. So, okay, great. So this is, I would say, moderately risky. The next one to look at is Coin. So Coin was last published in 2023, so much more recently. That's great. I see some peer-reviewed papers, and that's really good. It does seem to have a website, which I really like. And all of those sorts of things are telling me this is looking pretty good. On top of that, when I look at the author, the maintainer has an rproject.org email address. Now, this is really good because if you're not familiar with R is like rproject.org means that you are pretty involved in the R community. You're helping with the like base R project. And so, you're probably going to continue to maintain this. This is someone who's like very, very involved in this sort of stuff. So all of that is really good. I'm thinking, I'm going to lean to using Coin as opposed to Pair YCI. So that's where I'm going to probably start. But before I make my final decision, I'm going to just do one quick thing and look at their downloads and their risk metric scores just in case. So looking at the downloads for Coin on this kind of random day, it's only one day, but Coin had 724 downloads. That's pretty good. Whereas Pair YCI only had 11. So a little bit more risky. And then looking at their risk metric scores, again, the risk metric score for Coin is a little bit lower. Both of them, I think, would be categorized as high risk or very high risk by risk metrics, which is not uncommon for these stats packages, oftentimes because these stats packages are done more like in a base R style. They don't have the things that risk metrics looks for, but that's fine. Given the peer-reviewed journals and all the other stuff that I talked about Coin, I feel pretty confident that that's going to be an okay place to start. So I start there. And I use a data set that is going to have these ties present, which is what we talked about, because that's kind of the extreme weird value. And when I do that, I use this data set because I wanted to make sure there's ties. So now I'm good. I have my data set. I have my package that I'm going to look at, and I'm going to compare it with SAS. So the data set I'm looking at is smoking versus non-smoking, which is not really related to our actual study, but because it has weird values and we're in an early dry run phase, so I don't have my actual data, this seems like a great place to start for me. So this is the values I get. Like in the p-values, they seem to match. I'm very happy with that. I'm not so worried. Then I look at the CIs, and actually they're kind of different. They're close, but they're definitely a little bit different. So I need to do some digging. So as I start to do some digging, I figured out a couple of things. First of all, both SAS and R have continuity corrections on and off, so I've turned them off because I didn't want continuity corrections. It didn't say to do that in my SAP. The other thing is it turns out actually p-values for the Wilcox-Rank sum test can both be asymptotic or exact. And looking here, you can see the asymptotic values between Coin and SAS match, but also the exact values for Coin and SAS match, but they don't really match each other. So clearly I needed a little bit more information in my SAP in order to be able to actually do an analysis with a number that would be consistent between Lynn and I, depending on if we chose for the exact or asymptotic. On top of that, when I look at my confidence intervals, I actually can match my confidence intervals if I'm using an exact method. So the Hodges-Lehmer exact method will give me, negative 0.76 on both sides as my lower bound and negative 0.1 for my upper bound. That's great. I can find a match. I love that. But for the asymptotic one, I can't get a match in COIN anyway. I actually can get a match when I'm using the stats package, and then I can match SAS. But again, it's really about being clear. So I wasn't clear enough in the SAP, in the original SAP, to be able to figure out what sort of methodology I needed for my p-value and confidence intervals, because although the general methodology was clear, it wasn't the kind of assumptions and exact information wasn't there. It's all of those little things that can really trip you up. So going back to our SAP, we have to do a little bit of editing here. The first sentence stays the same, but this time we are going to say that we're going to report out the Hodges-Lehmer estimate for the median difference between B versus A with the corresponding 95% exact confidence interval and the associated exact p-value without continuity correction, because that is what I actually wanted. Great. So with all of that information, Lynn and I are now matching between SAS and R, and we can go on our merry way, confidently knowing exactly how to reproduce this example when it comes to do the final analysis. And that is really the purpose of CAMIS. Although it sounds like looking at this exact versus non-exact and the continuity correction or not didn't take that long. Actually, it took lots of time of comparing between the different numbers and reading the documentations between SAS and R. And we're just trying to make sure that rather than every individual person do this and try and keep all this information in their head, that we can, or even every individual company do this separately to try and pool all this resource together, and together we will be able to be more flexible with the languages we use and use the best language for the task at the time, which hopefully will make everyone's lives easier going forward. So what are the objectives of CAMIS? First of all, it's to understand and document results discrepancies across software, like we saw with the Wilcoxon rank sum test, and then the associated Hodges-Lehmer. Then also demonstrating the methodology through examples. So if you look on CAMIS, there's a walkthrough example that shows you, actually using the data we have, how we got these numbers and exactly what you would need to do. The goal for you would be able to take the code there and run it exactly and get the exact same numbers that we have. We try to keep all of that up to date. The way this works is through an open GitHub repo, and really the goal is to grow the repository, increasing the quality and quantity of information. So what we're asking you today is, if you have knowledge of these things, please contribute back. And it's fine if you don't really know GitHub or anything like that, and you would need help with that, you can reach out to Lynn and I, and we're happy to help. The goal here is to try and bring as much of this information together as possible so that we all can kind of improve our own understanding of what's happening within our statistical software as we're using it. And with that, please ask us any questions. We'll type away. And the website is here. It's the psi.github.io/camis. And then, yeah, feel free to contribute back. If you have any further questions, you can follow up with us. And thank you so much for listening to us today.
Beth, we can see you.
There, it seems to be taking a while for my audio to actually turn on even once I click on it. So thank you very much for this presentation. It's really interesting. So I know there's some issues where SAS's answer isn't necessarily correct, or that authors have made a decision and one's not better or the other. So how have you been handling that?
For the most part, we're just trying to make sure that the information is there. I think the survival one's probably a really good example around how they do tie handling, because the tie handling that's default in SAS has been very concerned about backwards compatibility, which is great and fine, a valid place to come from. But it means that sometimes they stick with methods that are maybe not always recommended, because that's what they've kept. That was their default in 1982, so they've kept it. And so we try to, where there is a clear, like, this would be recommended in these cases, try to write that and be explicit where possible, but also it is a open source effort. So like we're some people write more of that information, some people write less of that information. And so if you know that information and are like, I would like to contribute back, we would love to have more contribution across a wider spread, but we definitely try and add that information in when it's available.
Yeah, I work with Terry Thurno, so I kind of have heard some of the backstories of issues that he's had on certain decisions in SAS. That
Yeah.
So do you have, I mean, how many people are actively working in this?
So I think we've had involvement from 42 different companies, so people within lots of varied companies, and people sometimes are researching a very small area and they just want to contribute that part to us. So they'll submit that, say, a year ago, and then, you know, not contributing on a regular basis. So you can really do as much or as little as you want. Some people that only use SAS just give us the information about how to do the analysis in SAS and pitfalls or problems they've experienced with that. And then we have people that are just work in R and would like to try and replicate that. And then they are often paired together to work together to see if they can get the comparison to match. And alternatively, if you can do SAS and R and you want to give us the whole lot, that's great as well. You can submit all the pages to us. So yeah, it's a really a broad range of people, and we have a regular meeting monthly for a core team to kind of get together, so you can be involved as much as you like.
So do you do training or provide kind of guidance if somebody wants to get started helping, or?
Yeah, we do training in a variety of different ways. The biggest training we've done so far, and what we've done the most of, is a lot of statisticians like, well, particularly a lot of people who've like worked in industry for a long time have never really used Git. Like they're great statisticians, but they're not necessarily like people who are on the internet all the time. And so we've done a lot of Git training. 2 years ago now, we did a training course with R and Pharma. We're just trying to get as much training as possible, but definitely we've done a lot of like one-off support to try and get those people because they oftentimes have so much great stats knowledge. And so it's good to try and marry the kind of tech knowledge and the stats knowledge together to bring it to everybody.
And I wonder if there's a way to give, there are packages that use some of these other basic packages that do the computation to give them feedback of this is one that, you know, maybe is more stable or has been vetted a little more or something.
Yeah, we try and do, as Lynn said, we do try and connect back to the package maintainers whenever it's possible and relevant. We definitely, through this process, kind of, it depends on who's writing it, but I know that some people who've written sections for us, anytime they're even slightly confused, they're kind of very willing to go and reach out to package authors and be like, I'm confused what's happening here. Like this documentation isn't clear in this section, and they're trying to provide a lot of feedback. And some people don't feel quite as comfortable with that, and that's totally fine. But yeah.
Yeah, so I think we're off onto the next talk, but thank you very much for this presentation. It was really interesting, and I may be connecting up with you.
Wonderful. Thank you, everyone.
Yep, bye.